me Chiku from Chiku Study Corner, and today we'll be dealing with the part 2 of coordination chemistry. So let's get into the video. If you haven't watched the previous parts, make sure you watch it and then continue watching. In the previous session, we learned about the important terms related to coordination compounds. So let's see what all was that terms. The first one that we dealt with was the one in the square bracket, that is called as the coordination entity, and the ion or that radical, positive or negatively charged radical that lies outside the square bracket is known as what? They are known as counter ions. And then we learned about what is ligands, we learned about what is central metal atom. Then what did we learn? We learned about heteroleptic and homoleptic ligands, denticity of ligands, bidentate, monodentate, polydentate, ambidentate, and chelating ligands. So over here, now we are going to discuss about something, another term, that is coordination polyhedra. So what is coordination polyhedra? That is the spatial arrangement of the molecules. They have specific arrangements. Those arrangements are termed as polyhedra, coordination polyhedra. So let's see some examples of those. So first one is very common. So we'll write the central metal atom as M and the ligands as L. So let's take, what is this? This is square planar. Then we have tetrahedral. This is tetrahedral. Okay. Then we have to talk about octahedral. So let's see what's octahedral. I'm drawing it much smaller. That is, octahedral would be like this. This is octahedral. Yeah, this is octahedral. Then let's draw square pyramidal. That is, over here, what is this? This is like this, okay? So now we'll draw square pyramid. There is metal 1, 2, 3, 4, 5, 6, and ligands. Sorry, over here it is not there. And what is that? This is the square pyramid. So these are some examples of coordination polyhedra. So what is coordination polyhedra? As I told, there is the spatial arrangement of what? Metal and ligands. Okay, central metal atom and ligands. They have specific arrangement, correct arrangements. Okay, so that is what is coordination polyhedra. So now let's see what is the coordination number. So to talk about the coordination number, what is the coordination number? Coordination number is the number of ligands, that is connected directly to the metal. So let's see. So coordination number. So what is this? Number of ligands directly bonded to what? It's directly bonded to the central metal atom. Okay, so let's take the example K4 FeCN 6 times. So what is the coordination number of this compound? That is, how many Cn is connected to Fe. That is 6. Therefore the Cn is equal to 6 in this case. Okay, if this was 4, then Cn would have been 4. If this was 8, Cn would have been 8, etc., etc., etc. So it moves on like that. Now we have to learn about a term known as oxidation number. So let's see what's that. So by the way, I forgot to mention the previous one is for the coordination number, the number of atoms, ligands, that is connected directly to the central metal atom via coordinate bond. That was an important term. So what is that? That is connected via coordinate bond. So as I told you, now we are discussing about oxidation number. So what is oxidation number? It is the charge carried by the central metal atom if all ligand molecules or bonds that are attached are removed. See, I told you these ligands should be removed. When these ligands are removed, even the electron pair should be removed with the electron pairs. Okay, so that charge that is carried by the central metal atom when the ligand is removed with its electron pairs is known as oxidation number. So this oxidation number is always written in small brackets with the number in Roman numeral. Okay, example is what I wrote. It can be like this, it can be like this. Let's see a few examples. So let's take the example of FeCO 5 times. So what is this? There is no square bracket. Then how is this a coordination compound? I told you carbon monoxide CO, if it comes, if there is a square bracket or not, it can be written any way. But if you don't write a square bracket for other, species of these compounds, that is wrong. Over here it is fine. Yeah, I told you in the beginning, the first portion I told you about this. So let's see. So first we'll write the coordination number. So coordination number is equal to how many? 5, because Fe is the central metal atom. So let's make this in a box for your better understanding. So Fe, what is the number of ligands that is connected directly via coordinate bond to the central metal atom? That is 5 numbers. So that is the coordination number is 5. Then now we have to see about the oxidation number. So oxidation number. So what is the oxidation number? Let's see. Fe. We have to find out for Fe. So let's make it X plus. What is the value for carbon monoxide? It's 0. What the oxidation number for carbon monoxide is 0. So 0 into 5. Am I right? Therefore, what is the value of X? X is it's into, okay, not plus, into 5. So X is equal to 0. And therefore, how would you write this? That is Fe bracket 0. Because you have no Roman numeral as such for 0. So this is how you mark this. So now let's see one more example. So a regular example, what is that? K4FeCN 6 times. Am I right? So let's see what is this. What's the coordination number? Coordination number is equal to 6. So now let's see the oxidation number. Oxidation number. So you can see there's a radical outside. What is the charge of this radical? This is plus 1. Plus 1 into 4 is 4. Am I right? This is plus 4. Plus, what is the oxidation number? We don't know. So what would we mark it as? X or Y or Z? Any variable. So X plus, what is the charge of Cn minus, what is the charge of Cn cyanide? That is minus 1. So how many is there? 6. So minus 6. So let's take this and solve this. So minus 2 is equal to x, sorry, minus 2 plus x, and what is x? X is equal to 2. Yeah, x is equal to plus 2. So let's write the oxidation number is equal to plus 2 I'm sorry, and hence Fe is equal to 2, because I told you we'll write it only in Roman numeral. Okay, so this is the talk about oxidation number. Now let's see the charge on the complex. So let's see what is the charge on the complex. What is that term which is termed as complex? That is the entity. What entity? The coordination entity is called as the complex. So the charge carried by it is what we have to find. So let's see what's that. So what is the charge? That is the charge, the algebraic sum, okay? The algebraic sum of charges carried by central metal atom and also the ligand. Okay, so what is this? This is the charge on the complex. So let's see an example. So let's write example K4FeCN 6 times. So let's see what's the charge over here. So what did I tell you? That is the overall charge carried by both this ligand and the central metal atom. So let's see. So what is the charge carried by Fe? What is the charge? That is 3. And what is the charge of Cn? That is minus 1 into 6. So plus 6 into minus 1. Therefore 3 plus minus 6 is equal to 0. And what is the, not is equal to 0, I'm sorry. 3 plus minus 6. So this implies what is the answer? That is minus 3. So the charge carried by this complex is minus 3. Okay? So that is the charge on the complex. Now we have to learn about something else. That is the different types of the complex. That is, there is anionic, cationic and neutral. So let us see the examples of each of them. What are the examples for the cationic, anionic and neutral complex? So let's write complex, and that is divided into cationic, anionic and neutral. So let's write the example for each of them. So for cationic, the example is cobalt. Okay, cobalt NH3 3+. And for anionic, it is anionic it is FeCN 6 times 4 minus. Okay, and for neutral, what is that? That is NiNH3Cl2. Okay, so this is the example for cationic, anionic and neutral. So for cationic, what is that? The charge is positive, and for anionic the charge is negative, and for neutral there is no charge. It's a balanced one. So that is the talk about the important terms. Now let's see about the nomenclature of these compounds. The nomenclature of these compounds are very important and it's asked frequently in your question papers. So let's see what's a nomenclature and its rules. So let's see. Nomenclature. Before that, I would give you a table in which you have the names of these ligands, okay, like oxalator and chlorido, etc. There are so many names, amines, like that. There are so many. So I'll give you the list. Okay. So Nomenclature. What do you mean by nomenclature? The naming. So, for the nomenclature, there is some rules given by our IUPAC. Okay, the IUPAC rules are important in the naming or for the nomenclature of coordination compounds. So, let's see the first case. In the first case, if it is K4FeCN 6 times, then this is the counter ion comes first, and therefore when you write the nomenclature for a compound, the positive part would come first and then only the negative part. Okay, so in this case, which is the positive part, this is positive and this is negative. Am I right? So this K4, that is potassium, would be just mentioned. You won't write tetrapotassium or tripotassium. You just write it as potassium. Okay. And then over here, when you write the name of the ligand or of the coordination entity, you will first mention the ligand and then you will mention central metal atom. Now we'll take the second case. Okay. What would we write? We'll write CrNH3 6 times Cl3. This is a square bracket. Okay. So over here, where is our counter ion coming? It is coming towards the right hand side. I told you, excuse me. I told you that K4 is positive and Cl3 is negative. Whatever comes first is mentioned first. So over here, the coordination entity comes first. So you will mention about the coordination entity. So this is negative and this is positive. So over here we wrote potassium. So what is over here? What would you call this as? This is chloride, not chlorine. You will write this chloride. Okay. So what is this? This is K4. When that comes in the first part, you will write this potassium. If chlorine was, because chlorine will not come in the first part because it's a negative one. So this portion is called as the counter ion coming towards the left hand side would be named as such. Example, potassium. And the counter ion coming in the second half or in the right hand side would be named as chloride, for example. IDE is added to the end of the name. So now you can see a difference that comes in this. Now we've talked about what the counter ion. Next we have to learn about the entity, the coordination entity. So if this is negative, if our ligand is negative, then how will you write? This is FeCN6. Whenever, if it is a positive or a negative one, whenever you write the coordination entity, you will mention the ligand first. And then you will write about the, central metal atom. So, over here CN6 is, what is CN6? I'll give you the list, you will understand that. So, you will write the name of that and then you will write ferrate. Okay. Now, you won't write it as iron, you will write it as ferrate. If this was like this, let's take an example. If something was formed like this, it's an example. So, then what would happen? Then this would be written as what? The name of the ligand plus the name of the metal. So, you will write it as the ligand. Example over here we have taken iron, no? So, ligand iron. Okay. So, what is this over here? Over here, that is chromium itself. It's not chromate, it's chromium. Okay. Over here, what was the case if this was it? This is ferrate. Ferrate, and this is chromium. So, I think you might have understood what my point is. The last rule is, if En, etc., the ligands like En comes in the coordination compound in more number, that is multiple En molecules or molecules like that comes, what happens? You will not name it as triethylene 1,2-diamine. Instead, you will name it as tris-bis and like that. Okay. So now let's see the example and how will we do this. So now you see this table. The table is very important. You have to learn it by heart because nomenclature is a very, very important question for your board exams. So this is the table. So now we'll discuss two examples. So the first example is K4FeCN 6 times and the second one is CONO2 6 times 3 minus. So let's name both of them. For naming this, before that I told you this example before. So Fe is written as ferrate. Why is that? Why can't we write it as ionate? It is because when the central metal atom is in the negative part, that is when the coordination entity has a negative charge, what happens? Then the name of the central metal atom inside the coordination entity would be written in the Greek name with ATE in the end. So let's name this. So first what would be right? We would write, I'll write the second example later. So let's write this name and then we continue. So I told you what do we write first? Always positive comes first and negative follows. So the positive one over here is what? Our potassium. So let's write potassium, and then I told you we'll write about the ligand. This ligand is known as cyanido. Okay, you write it in that table, cyanido. So how many cyanido ligands are there? There are 6 of them. So how would you write it? Is there is 6 cyanido? That is hexacyanide. Potassium hexacyanide. Then what would we write? There is no space, I am writing it down. Then we will write it as ferrate. So I told you we have to mention the oxidation number in the bracket in Roman numeral. So let's write that. That is 3. Okay. Now let's see the second example. What was our second example? Cobalt, CONO2, sorry, CONO2 6 times 3 minus. Yeah, was this our example? So let's write this. Over here, can you see there's a charge and there is no other counter ion. So what is this? Counter ion plus this entity would only make a coordination compound. This is just the coordination complex, and this coordination complex is also an ion because it has negative charge. So when you write this, when there's a charge above, you have to mention ion in towards the end. Okay. So now let's name this. So how do you name this? Let's see. We have 6NO2. So nitrito is 6. So how do you write nitrito to be 6? We'll write that. Let's see. So over here also this is a negative entity. So what would you write for CO? You will write it as cobaltate. Okay. What? Cobaltate. So let's write it. Hexanitrito. By the way, NO2, I said NO2 is an ambidentate ligand. So for this ambidentate ligand, which form is written over here? It is not ONO written, no. It is NO2. What is the name of NO2? That is nitrito. N. Am I right? So we'll write it this in the same way. There is no space between these. Okay, don't leave space. So hexanitrito N. I told you what is this? Not cobalt, it is cobaltate because this comes as a negative entity. So cobaltate. Then we will write the what? Its oxidation number. So what is its oxidation number? 3. So I'll write it down because there's no space. So this is the nomenclature of this compound. So I hope you might have understood this lecture. If you have understood this, please do give my video a huge thumbs up and also subscribe to my channel if you're new to it. Also share my video with your other friends. Please do check out that table in my description because you have to learn it for better understanding of the nomenclature. So see you on my next video. Till then, bye-bye.